Okay, this is the second video about continuity, and this is involving continuity and what's called a piecewise function. And so with piecewise functions, oops, I just noticed my papers are out of order. There we go. With piecewise functions, they take this form where we have f of x equals a couple of different functions. In this case, it just happens to be two. And what this does is this gives us the what the function is, and then this gives us the where it's happening. So this function is going to be negative x plus 3 for any x's that are less than 2. So when x is less than 2, I get this line x equals, so there's our slope of -1 going through 3. So all the way up until 2, I'm drawing this line. But then at 2, something happens, and we say when we equal 2, now it's just going to be y equals 4 or f of x equals 4. It's just going to be this constant. So that's a piecewise, is where there's two different functions or more happening on a single graph, and we're defining it in terms of the pieces. And so now we're just trying to figure out where this graph is continuous and where it isn't. So at x equals 1, that is continuous because the point exists, the limits are the same from either side, and those two things are equal. Basically, it's a graph, and I didn't have to pick up my pen. At 2, it is not continuous, right? Because there's this big old jump, so my limits are not equal, so that would be a no. And at 3, everything's fine, right? There's a point, I'm coming in the same point left and right-hand side. So that will be a yes. And so now this is the same idea, but this time without the picture. And so here they're giving us 3 x's again, and there's nothing funky. This is a line, this is a constant. So at 4, it's gonna be continuous, right? Because it's just, you're just plugging in 4, the value would come out 2, it's gonna approach 2. The point where there's issues is right here at the boundary. So now if I let x equal 5, even though it says not to, I'm going to see where it would have gone. So if I let x equal 5 in this one, it goes to 3. Here, there's no x, it's always 3. And so in this case, these are going to meet at the same spot. My graph would be something like, it would be coming up, and then this one would meet it and do that. And so this is going to be continuous, and so we would say yes. And then at 6, it would be continuous because it's always 3. Same idea down here, but now we're just checking that 1 point on the boundary. So if I put 1 into here, I get 2 times 1 plus 1, and that would be 3. And if I put 1 in this one, I get -1 plus 5, and I get 4. So you can see on this one, I have 2 lines, and they're going to do something like that. So they're heading to different points, so the limit doesn't exist, therefore the function isn't continuous.